Inspect a primary and secondary flight control surface. The condition of flight control surfaces plays a direct role in how safely an aircraft flies. Even a worn hinge, a stiff linkage, or a loose fastener can lead to serious control issues in flight. That's why every flight control surface must be inspected carefully for condition, attachment, and movement. To inspect a surface correctly, it's important to first know what type it is. Flight control surfaces are divided into primary and secondary types. Primary surfaces include the aileron, elevator, and rudder. These control the aircraft around its three axes. Secondary surfaces include flaps, slats, spoilers, and trim tabs. They assist or adjust movement, especially during takeoff, landing, or high-speed flight. Each primary control surface moves the aircraft around a specific axis. Ailerons control roll along the longitudinal axis. The elevator controls pitch along the lateral axis. The rudder controls yaw along the vertical axis. Knowing this supports accurate inspection and troubleshooting. Let's begin with the ailerons. They are located near the wingtips along the trailing edge and move in opposite directions to control roll. Check the hinges and linkages for wear. The surface should move freely, with all fasteners tight and balance weights properly secured. After the ailerons, the next surface to inspect is the elevator. It is mounted on the horizontal tail and controls pitch, moving the nose up or down. When inspecting the elevator, check hinges and attachment points. Check for smooth movement through its full travel. If a trim tab is present, make sure it's secure and its linkage is free of wear or binding. After the elevator, the next surface to inspect is the rudder. It's mounted on the vertical tail and controls yaw, turning the aircraft left or right. Check the hinges and control cables for wear or damage. Confirm the rudder moves freely and that the linkage, horn, and balance weight are secure. Beyond the primary surfaces, there are secondary controls that assist flight. Flaps extend from the trailing edge to increase lift at low speeds. Slats on the wing's leading edge help delay stall. Spoilers reduce lift or help with roll control. Inspect these surfaces for cracks, secure fasteners, and proper travel range. Another group of secondary surfaces includes the control tabs. Trim tabs reduce the pilot's workload by holding a control surface in position. Servo tabs help move larger surfaces, while anti-balance tabs add resistance for better feedback. Inspect each tab for freedom of movement, surface cracks, and secure linkage or fasteners. Across all control surfaces, certain inspection checks always apply. Each surface should move freely through its full range without resistance or play. Fasteners must be tight, with no missing hardware. Linkage rods and hinges should be clean, properly secured, and free from visible damage, corrosion, or bending. Every flight control surface plays a role in how the aircraft responds in the air. When even one surface is damaged, stiff, or loose, flight stability can be affected. That is why surface inspections must be done with care, attention to detail, and good judgment. They are a key part of ensuring airworthiness.